So the answer to the question definitely is yes, you may use this paper and the other paper that you're going to write your answers on the quiz. And there were other kids who were confused. We didn't actually take quiz 1 yet, and I know that, but a whole week and a half has gone by and you've learned some more stuff. So I'm condensing quiz 1 and quiz 2 together. And actually, I'm not going to lie, I'm not even going to bother giving you the unit test. So this quiz 1 and quiz 2 is basically your unit test, because we're moving on to unit 3 as soon as we're done with this. Okay, so I've been given this graph, and there is the equation of the graph. And I'm letting you know that I'm calling it the Z graph, and that's my graph. I just wanted to use a Z today. And when you are doing this in Desmos, there is an absolute value character in there. It's hidden. If you look inside of the of your options on the keyboard, they'll show you where the absolute value is, or you can use these letters. And what it means is put the 2x minus 3 inside of the absolute values, put the minus 10 on the outside. And by the way, I did make it so that you could see all of these points have been marked for you, so you could see what those points are, okay? And I'm sorry that the very first thing I did was I asked you about a question, but I legit forgot to teach this. What is an axis of symmetry? It is the halfway point in the V. So it's right here. So go ahead and mark it. That's your axis of symmetry. It's where you could fold this shape in half and the two red lines would meet up exactly, okay? And the axis of symmetry, you can find it anytime you look for the vertex, which is funny because that's the second question, is what is the vertex? Well, let me tell you, the vertex is right here. And so you can go ahead and write that down. 1.5 and negative 10 is where the vertex is, okay? And I'm saying then, well, what about that? You said the vertex helps me find the axis of symmetry. Yeah, it totally does. And specifically, this number right here. This number is the equation of this dotted line. So I have this dotted line, and if I were trying to graph it on Desmos, this is what I would type in. X equals 1.5. And by the way, Desmos does have dotted lines. If you ever wanted to do that, you totally can. So now that we know what the axis of symmetry is, you might want to know what it's used for. And so in a physics problem, sometimes you want two things to be equally distant from one another. And we call that equidistant. So if I wanted to say that this point is exactly the same distance away as that point, we would find that middle point, and the axis of symmetry would tell us where that middle point is, okay? That's what we use it for. Now, in this class, we just have to identify it. We don't even need to use it. We're just going to identify it, okay? Now, the next piece, these next two questions come from Math 1. What is your x-intercept? What are your zeros? What is your y-intercept? And I'll tell you, x-intercept, you should have heard. Y-intercept, you should have heard in your Math 1 class. And they have all been marked. So this is my x-intercept. This is my x-intercept. And this one down here is my y-intercept. But if you didn't get a chance to learn this before, let me just throw down the definition for you. Ready? The definition is where the graph crosses the x-axis, okay? And this definition is where the graph crosses the y-axis. Now, what you have not heard is this right there. What does that mean? The zeros. That's something I'm supposed to introduce right now. An x-intercept is the same thing as the zeros. Well, shoot, we had trouble remembering what an x-intercept was. Why would we go and try and learn yet another word for x-intercept? Well, the thing is that, you know how lazy I get. If if y is 0, which right here, it's telling me for both of those points, y is 0. And notice, I was just talking about this point. Hey, all along that line, y is equal to 0. And so it matters to me where the x-intercept is, because I want to know when am I crossing over from my function having negative heights and negative heights are all of these heights down here. So this is the negative height, negative height, negative height. There's a negative height, negative height, negative height. Where do I have all these negative heights? And where do I have all of my positive heights? And so the zeros tell me when I'm swapping over. Okay, it tells me when I'm swapping over from one to the other, from positive to negative or vice versa. Okay, so now that we have all of that, let's actually write them down. So the x-intercept is at negative 3.5 and the y value, again, remember this, it'll always be 0. And then the other x-intercept is 6.5 and also the y value is 0. The y-intercept is down here, and I had it marked, and I'm sorry I erased it. My y-intercept down here, what do we use that for? Well, in a real-world problem, I would call this the time axis, and if I was doing something with physics, I like to measure stuff over time. I got a rocket ship that it's traveling over time. I've got that telescope that's out in space. It's traveling over time. And so I always want to know, what's my initial time? What were we doing when we started stuff? And so if I was talking about this graph, I'd say, well, it started at negative 7. You know, in time, there's no such thing as negative time. So this axis would just kind of disappear and I wouldn't be talking about it anymore, okay? So where I start is at negative 7, and that's why I care what the y-intercept is. Remember that the y-intercept is probably a number, but this should always be 0. Just like the y values should always be 0 when you're looking for the x-intercept. It's kind of funny how they swap like that. All right, so now that we've talked about those 3 things, we're on to the topic of domain and range. And on every test that I give you, there's always a gimme. So ready, the domain? The domain is all real numbers. And I know this sounds crazy, and I apologize for it. But like, what do you mean real? Like, you know, everything's real, right? Like in math, isn't it all real? It turns out, I know I'm sitting in the back of the room so you can't see me, but it turns out there is something called imaginary number. Yeah, we're going to be like in kindergarten, and then when you're going to come in the room one day and we're going to imagine some stuff. We're going to find where the imaginary number is. We're going to be making some things up. So real numbers are numbers that you already know, like positive 10 or negative 10 or a decimal like 0.2, or even square roots like the square root of 100, or even a square root that you're like not sure what it is, the square root of 2. I know that it's 1.4041414, but you guys are like, I don't know what the square root of 2 is. It's still a number. You can use a calculator to find it. Imaginary numbers, I'll teach that on another day. We'll get there, okay? So for today, and what you need to know for this test, put a little star next to it. The answer is always all real numbers, okay? Specifically, I will also mention that for the kids that haven't been in the room when I went over domain and range, there is a video for you to watch. There's Khan Academy for you to do. Make sure you catch up on that. And if we were using interval notation, again, one of the things I've been teaching over this week, you could write it like this: negative infinity up to positive infinity. That's all real numbers, okay? So you could write down that first sentence, or you could write down that second thing, and it's totally fine with me. In fact, all of these other questions, all the way down to 11, actually, all of these other questions, you have choices when you write stuff down. So write down the part that makes the most sense to you. You don't have to write everything, all right? When I'm talking about the range of my graph, there's where something specific is happening, okay? There's definitely a space on my graph where it doesn't exist. There's no red line down here, okay? So that means, ready? My range is restricted. My function cannot go down there, meaning this right here is called a minimum. And I'm sorry, but when I asked about the vertex, I meant to say it is a minimum. And so I'm adding that on as an extra credit question. So you've got number 5, which is a gimme. The answer will always be all real numbers. And you've also got this extra credit right here. If you can figure out that this is a low point, and you can write down that it's a low point, then you'll be all set. Okay, you'll be all set. You're going to get that extra credit, and the other one, you're going to get it right. It's going to be great. So if my range is restricted and I can't go any lower than -10, then my range has to be that y is greater than or equal to that -10. Does that make sense? I'm going to zoom in on it. The range has to be that y is greater than or equal to 10, or else, or else it would go down to -11, and it doesn't, okay? The complete interval where the function is positive and the complete interval where the function is negative, that might feel like you've never heard that question before, and I don't blame you, because when we were doing Khan Academy would ask you, like, from here to here, is your function positive or is it negative? And you'd be like, looks like it's positive. Looks like it has some positive heights there. It would say, oh, well, how about from here to here? Is it positive or negative? And you say, oh, it's definitely positive. On the test now, I want to know the whole piece that has positive values, and I want to know the whole piece that has positive values. And on this V shape, there are two of them. Okay, there are two areas where my function is positive, and they start at that number and they start at that number. Okay, so what I wanted to say for the kids who have missed out on interval notation, this is what you can write. You can write x is below or equal to -3.5 and x is above 6.5. That's a sentence. You can write that and get credit for it. Math 2+ kids, I would really like to see the inequality or the interval notation, okay? The inequality is x is less than -3.5, and you don't have to include the equal sign, by the way. Both of you guys, you can include it or not include it. I'm not stressing about that. That part doesn't bother me. So there's one set of answers. We're just going to leave off the equal sign because it stresses you out. Right here is another set of answers where you say, oh, here, can we use the word and? Because the other place is where x is greater than 6.5, and that looks nice. I think it looks nice, okay? If you're doing interval notation, it looks like this, -infinity up to 3.5, that's negative. And you use this union symbol right here, that's a U. And then here you do the 6.5 and it goes up to positive infinity, okay? So you have all these choices, all these ways that you could write the answers. Pick one and write it down. And I think it's a little bit obvious that all the blue stuff is where stuff was positive and that everything else has got to be where it's negative. But just for fun, I'm gonna highlight it because I found my pink highlighter and I think it's pretty. Down there, all of that. And by the way, it starts right here and it ends right there. And for all of us, I've seen kids say, this actually makes total sense to me. This could be the first time you see it, but watch this. You start at -3.5 and you go up to 6.5 and you put x in between. Do you see it? A lot of kids just see, well, that just seems natural. I totally get what you mean. But if you wanted to do interval notation, it's even more tight. You have even less to write, and I think it looks nice. So you could write either one of those answers. And you could also write the sentence, x is between -3.5 and 6.5. And, I wonder, do you really want, number 8, do you want me to write that? X is between -3.5 and 6.5. That answer is so easy to write. I totally believe in you, okay? You're going to be able to do that. Now, when I was talking about that vertex, the reason why the vertex is important is that the direction of the graph changes. So I'm going to draw all over my graph and then I'm going to erase it. Ready? The graph, we were going downhill till we got to there, and then we're going uphill. So that's the difference between increasing and decreasing. This section right here is my decreasing, and actually let me pull out another color, this orange. This is where I'm increasing, okay? So if I was drawing some dude and he was, going down this hill, he hits the bottom, and then he starts to go back uphill, right? So that's where we were decreasing. That's where we were increasing. And the beautiful thing about finding that vertex is that's the number that we're going to use. So here's the number. It's 1.5. The x value is 1.5, and I say that x is less than 1.5. From there, we were decreasing, and x is greater than 1.5. From there, x is increasing. Now, I don't know if anybody's digging the interval notation or not, but I'm going to go ahead and throw it down there just in case you wanted it. We do negative infinity up to 1.5, and then we do 1.5 up to infinity. And those answers are optional. You pick one. Even if you're in Math 2 Plus, you could pick either one. Or you're even allowed to do a sentence here. I just wanted to teach it and make sure that you felt like good about it, but you don't have to write all of them down, okay? I know this has been a long time. I know I was writing fast. Here's the last two questions, okay? It says, number 11, find a particular point that is a solution to your function and show that it creates a true statement. Make sure that your point is labeled on that graph. Okay, I got a lot of things on my graph. I'm about to erase all of them. Okay? I don't need any of this stuff anymore. I just want to look at my graph. I just want to figure out what are points that are on my graph and what are points that are off of my graph. So here it is. Ready? This point's on, this point's on, this point's on, this point's on. You could use any of these points for number 11. You are allowed to use any of these points for number 11 because all of these points are on the graph. Do not use this point. Why not? Well, it's a fraction. It's a decimal. We don't know exactly what it is. I don't want you guessing, okay? If you want to use some other point that hasn't been marked for you, make sure that you find an intersection. This intersection, by the way, is 4 and negative 5. So x is 4 and y is negative 5. So, I mean, I've given you points that you can use. If you wanted to be adventurous and find your own point, feel free. But make sure it's at an intersection, like right here. Make sure that it's at an intersection, like right here. Make sure that it's in an intersection, like right there, or like right there, where you actually know what those whole numbers are, okay? Nobody's asking you to plug in something hard. We want easy numbers here. So now I'm going to do number 11. And I got to remember what the original function was. Z of x equals, it was absolute value of 2x minus 5 minus 10. Let me just double check that. I'm looking up here. Ooh, it was minus 3? I'm sorry. It's a minus 3. Okay, I feel bad about that now. That makes more sense. Okay, so I'm checking the point 4 and negative 5. And I know you know that that's an x value, and I know that you know that's a y value, but a lot of kids are like, but where does the y value go? Like if you rewrote this equation, you got the absolute value, you got the 2, you got the x minus the 3, you know how to plug this in. So I'm going to make this pop. There's my x, it's a 4. I plug it in right there. But where does the y value go? You're like, I don't see a y. What you need to remember is that that's the same thing as a y. And so the y value, let's make that be purple. The y value, I'm going to put it in, ready? Right there. And I am asking a question here. Are those things equal? I don't know. Let's figure it out. 2 times 4 is what? And 8 minus 3 is what? And the absolute value of 5 is what? And 5 minus 10 is what? It is definitely negative 5. This is true. So it satisfies. If you get a true statement, then it satisfies. And by the way, this is a 2-point question, okay? Because you need to pick the point and then you need to check it. And so I'm going to give you a point if your point actually is on the line. And then I'm going to give you a point for actually checking it. And neither of these points are extra credit. This is just a 2-pointer. Because sometimes the kid will make a mistake somewhere in here and I don't want them to not get anything at all. So if there's something that's correct in here, you're going to get a point. All right? Sometimes you get a little bit off, you get a little bit nervous, whatever. So you might not get both points, but you definitely will get a point. Okay? So that was 11. I'm checking to see if a point was on the graph, and indeed it was. Number 12 is super hard because you guys are like, wait, what? Yeah, let me show you. Right here it says find a particular point that is not a solution. We just did is a solution. Now let's do one that is not a solution. And I need you to know what not a solution looks like too, okay? So what not a solution looks like is this. That point right there is not a solution. That point right there is not a solution, 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 not a solution. All of these points are not solutions. Why? Because they're not on the line. You know, if they were on the line, then they would be a solution. So my favorite one, I've marked all of these different points. Pick any one of them that you want or any other point that you see up there. But I'm just letting you know this one's my favorite right there, 0, 0. Because one number is 0 and the other number is 0 is super easy to use. It's called the origin. But I really need you to pay attention, okay? Because what if on the day of the test, what if I gave you this graph? Ready? What if I gave you this graph? Hold on. Let me make it more careful. Can you use 0, 0 to check that this is not a solution? No, because then it's on the graph. So I'm not guaranteeing that that's going to happen to you, but that might happen to you. Today, this point is not on the graph. So let's check it. Check the origin for fun. Because I like plugging in 0, 0 anytime I can. All right. So now I'm going to go down here. And again, I'm going to write down my equation. It's z of x equals 2x minus 3 with the minus 10 on the outside of the absolute values. And then I'm going to check that, and I say that I have 0, 0. I'm going to have my 2, my x, my minus 3, my minus 10. That's equal to, ready? I think I put blue was 0, and purple, is also 0. So I am checking to see what happens here. 2 times 0 is 0. 0 minus 3 is negative 3. The absolute value of negative 3 is what? And 3 minus 10 is what? Negative 7? Well, is that true? Not true. Okay, so good. That's a point that is not a solution. This is not a solution because I got that fact that it was not true. Okay? So there you go. I kind of went fast.